if you remember the problem, our initial goal is to reach from 0th to the maximum of n. So we'll initialize our DP with 5 indices. If let's just say we are here, how many steps for us it takes to reach in the 5th step? It is the base case, which is 1. Same goes, let's just say if we are at 4, how many steps it takes to reach the top, which is 5. It is also like 1. And if you think about it, no matter if we even get like 200 steps or 1000 steps, these two will always remain same. So let's just say if you are at 3, so either you can take this one or you can take this one. But here's the catch. Since we already know if we are at 4, it takes us one step to reach at 5. And if we go to 5 also, we know that it takes one step to reach at 5. So this 3 will be addition of last two steps, which is 1 plus 1, 2. And similarly, if we go to on 2, we know that the last two value of these two, which is 2 plus 1, 3. Similarly, if we go to 1, it will be 3 plus 2, 5. And if we go on 0, it will be 5 plus 3, which is 8. And this is what we need to return. We are still taking O of n memory space for this. But do we actually need that? We only need like the last two elements. Right here, we only need these two elements. So we will initialize our variables for this. We can call it 1 and 2. And that's how we can only use just two variables. And that will make our space complexity as O of 1. And the code is very simple. Let's quickly look at that. Here, we can start by defining our variables, which is 1 and 2. We can initialize that both of them with 1, 1. And now we can start our loop with 0 and go up till n minus 1 because we already have two values. And now we have to basically swap the values. We can use a temp variable for that. R1 will be equal to 1 plus 2 and 2 will be equal to temp. And we just have to return our 1. Let's run it. Yep, this works. Yep, this works. Hope you found this valuable. If yes, you can consider subscribing to the channel. And